And here we go. All right, so hope everybody's having a good day. We're halfway through the short week. What is happening tomorrow? Okay, you got your exam. Okay, so the main part will be the compound and simple interest problems on there. That's the majority of what you're going to see, but there's also, some currency conversion, which is just proportions. You'll also have a little bit from this lesson just in being able to identify if something is a function or not. So that's really just review. Hillary? I think I'm going to do like we did yesterday. I'm just going to go ahead and let you use your notes. Now, I would still encourage you to go ahead and prepare, take some time to look over everything, but you'll be able to have those. So it's not necessary to memorize them. In fact, a lot of the stuff on the paper exams, you're going to have the formula booklet, which I've already shared with you. It just doesn't have everything in there, like the statistical tests. You definitely need to know how to do those on the calculator. But, as of tomorrow, what are we, 4 weeks from the IAs being officially due? Okay, so not a lot of time left. You still have a good month, but if you have any questions or anything, please let me know. We spent all last week. Hopefully, I was able to help some folks out or give you some good ideas. Just let me know if you need anything else. We'll continue to just keep working on it, and we'll go from there. Okay, so I think that's everything I got. We got the test tomorrow, so on Friday we'll most likely go ahead and review, reteach anything on the exam that people found difficult. Okay, is there any questions you guys have? No? Okay, well, I'm looking forward to the next couple weeks because really this is almost going to be a time, I think, for us to kind of just slow down. We don't have to worry about new material per se. It's just going to be a lot of algebra review. We have this relations and functions lesson here, and then we'll get into linear functions. We have another packet. I'm going to go a little more detail into quadratics. Then we have exponentials, and then we'll be able to get into our last units of the school year. So we're really on track for the way everything should be going. We should have, I would say, estimate at this point, probably a good 3 or 4 weeks before the paper exams to just go ahead and review and take some practice exams and kind of see what happens. Okay. Well, let's see here. We are talking about functions and relations. Now, a relation is a set of ordered pairs. It's not necessarily a function. In fact, anything you've ever come across is a relation. It can always be defined as such. Any graph, because it's just created using a set of ordered pairs. And they're broken up, into 2 parts. Domain, which is x, the set of all the first elements of a relation, which are the independent. And range, y, the set of all the second elements of a relation, the dependent variable. In fact, from way back when I taught Algebra 2, I went ahead and put in some extra vocabulary. So I'm looking at some folks I taught Algebra 2 a long time ago. Does anybody remember another name for the elements in the domain or the range? One starts with an A. It's not going to be on the paper exams. They don't do anything like that, but I'll just kind of see FYI if anybody remembers. It's been a while. Does anybody remember abscissas? Okay. The elements in the domain. Do anybody remember what we call the elements in the range? This one starts with an O. Ordinates. Does that sound familiar? Abscissa is an ordinate. Okay, there you go. Little FYI for you right there. So you can go tell your friends, hey, do you know that elements in the domain are also called abscissas? Really? Tell me more. I imagine that's kind of how those teenage conversations would go nowadays. Yes. Okay. I am just as funny as I was yesterday. Okay. Let's continue going. So a relation is defined by the rule. Here's our first example. Y equals x plus 2. So this is just a linear function, y equals mx plus b, where x belongs to this set. So these are the only values of x that we have for this one. It says determine the range of the relation. Okay, so the y values. Well, how am I going to do this? Yeah, we're just going to go ahead and plug these in. Now, it comes up later in the lesson, but I'm going to go ahead and start to plug these in using a particular notation that you're going to be really familiar with. Like, let's say I want to plug 0 into this function. This is the same as saying f of x is equal to x plus 2. Does anybody remember what that notation is called? Well, no, that's the form of the line, but I'm talking about that f of x. What kind of notation? Okay, that's what we call function notation. Okay, that just kind of addresses the relationship between the independent values x and the dependent values y. So they're interchangeable. F of x is the same as y. And a lot of times you'll notice you'll see g of x, k of x, m of x, basically whatever variables you want, because you could be dealing with multiple functions at once, and it's just the name of the function. So I could call this function f, so you would know exactly which one I was referring to. Is everybody okay? You guys remember a lot of that? Okay. So if I wanted to go ahead and do this, for example, I would go ahead and say f of 0. And you've seen that before. Whatever value is in parentheses, that's your x value. So I'm just going to replace every x in the equation with that. So x plus 2 becomes 0 plus 2, which is just 2. So I can go ahead and create a set over here for the y values. So the first one being 2. And then I could do the same thing for the very next one. The next x value is 1. So I can go ahead and say f of 1. So that would be 1 plus 2, which is equal to 3. Okay. And then I could continue going on. F of 2 will give me 4. F of 3, 5, and F of 4, 6. There you go. So those would be the range elements. Okay, my ordinance. Okay, that's easy, right?
Yes.
Okay. See, I like this stuff because I function well in this domain. Well, they're all good with you. Yeah, it's true.
This was a better.
Thank you, Spencer. I appreciate that. There's differing levels of greatness. Okay. Yes. All right. So express the relation as a set of ordered pairs. Okay, so I'm going to create just a set here. So we know when x is 0, y is 2. When 1, we have 3, and then so on. Okay, so we're just going to create a relation. And there's a lot of different ways that you could view a relation. You could view it algebraically with the function itself. You could list it as a set. You could show it graphically. You can go ahead and describe it verbally. Okay, a lot of different representations here for these. So the next one would be 2, 4. The next one would be 3, 5. And the last one would be 4, 6. Okay. All right. Okay, so number 2, determine the domain, the x values, and the range of the relations. We have A, B, and C here. Okay, so let's see if we can recognize these first. If I were to graph it, what is A? Like, what is that a graph of? That's a what?
A quadratic.
It's a quadratic, yes. It's going to be a parabola. I know that the parabola is opening what direction?
Down.
It's opening down because A is negative. Okay, we know that its y-intercept should be what? 1. Okay, very good. What's B? It's a line. It's a straight line. Now, it's an inequality. I would want to go ahead and shade one part of the line that has the solutions. Do you guys remember that? Okay. We'll still go ahead and talk about the domain of that. And then this one right here. Okay. X squared plus y squared equals 4. It's a what? They get around. Oh, not a hyperbola. If it were a hyperbola, it would be minus. But good guess. It is a conic. It's a circle. Okay. It's a circle. Now, does anybody actually remember the general equation for a circle? Remember, we said it's back when we were dealing with conics, or back with your old Algebra 2 teachers, your pre-cal teachers, and you used the center as h comma k. Does anybody remember a circle? Anybody tell it to me? Okay. Does this look familiar? X minus h squared plus y minus k squared is equal to r squared. And what's the r stand for? The radius. Okay. So this is a circle. Even though it's in this form, the center would just be at 0, 0. And you can write a circle in the form of an ellipse, but I know this isn't an ellipse because if I were to divide through first, every ellipse, just like every hyperbola, has to equal what value? And I'm probably going way further with this than I need to, but I just like talking about this. Does anybody remember? It has to do with the eccentricity of the conic.
Oh.
Does anybody remember that word?
The eccentricity is like the.
It's the ratio length C divided by length A.
Yeah,
but it's basically a numerical value that describes the curvature of your graph. Does anybody remember it has to equal 1? For an ellipse and a hyperbola, if it's going to be in what we call standard form. Okay. Does this look familiar? Okay. So if I were to have x minus h squared plus y minus k squared equals 1, and then let's say I put a squared and b squared. Okay. And like I said, I'm probably getting way off topic here, but I just like to see, how much you guys remember when we're talking about this. Let's say in this case, because we're dealing with an ellipse, a squared is the larger value. So would this ellipse be running horizontally or vertically?
Vertically.
You're right, first horizontally. The larger denominator, if it's below x, it's horizontal. If it's below y, then it's vertical. Well, in this case here, you could still write it in standard form for an ellipse, but when you divide through, when you go ahead and make sure it equals 1, both your denominators are the same, letting me know that the major and minor axes would be the same length, so it's still a circle. Is this coming back to you? Okay. Would you like me to continue to do that, or you just want me to focus on what we have in front of us?
You can continue to do that.
Michelle, you like doing that? There, I like it. There we go. Okay. Everything comes full circle. All right, so let's go ahead and take a look at these real quick. Now, we want to go ahead and list the domain and range. So there is something that we haven't seen in a while, but you do use it a lot in pre-calculus and algebra, and even, beyond. I'm talking about interval notation. You guys remember the two symbols we used for those?
Parentheses and brackets.
Parentheses and brackets, yes. What's the difference?
Brackets are used if it's included. We use parentheses if the values aren't included.
That's exactly right.
Or with infinity.
Okay, bracket includes the value, parentheses does not include the value. So can anybody tell me, now this one's already listed for me, so we're told the x is the domain has to be greater than or equal to 0. So that one kind of already helps us out. What would that look like, though, in interval notation? Okay, it'd be bracket. There you go. That's exactly right. Okay. Okay. All right, now what about the range? Now, this is one thing I've found over the years. Some students are very able to, just look at the function and kind of visualize it in their head, but some other people like to go ahead and sketch it out and then list the domain and range from what they see. Would you like to go ahead and do that? Oh, do you have it, ma'am? Negative infinity to 1, yes. Okay, so negative infinity, again, not included like Eli told us, all the way to, put 1. There we go. In fact, would anybody like me to go ahead and draw it, sketch it to, that's it? Okay. So let's see here. We have our coordinate grid, and this is going to be a rough sketch. Now, we said it was opening what? It was opening down, okay. And the y-intercept was going to be at 1, so we're probably looking at something like this, right? But the fact that we were actually given that x has to be greater than or equal to 0, well, that's going to remove a portion of this graph. So while we still have this function, we're given this restriction. He can only exist from 0 to infinity, but he's still going to go all the way down to negative infinity. Does that make sense? Everybody okay with that? Okay. In fact, do you guys remember how to do one like B? You would go ahead and graph the boundary line, y equals 2 minus x, and then you would decide on what side you were going to shade. Okay. So let's see here. So 2 minus x, where's the y-intercept? It's at 2, so let's say 2 is right here. And with a negative slope, negative 1x, it's going to be rising or dropping to the right? Dropping to the right. So, again, just a rough sketch, let's say something like that. Okay. Now, I just went ahead and drew a straight line. Now I would go ahead and start looking at the inequality. You'll notice, what do I need to do? We are going to shade, but it's something about the boundary line. Should it actually be solid? Why?
Because it's not greater
There you go. It's only solid if you have equality. So I'll just go back here. There we go. Make it dash. So that means any point on the line itself is not considered a solution. Okay. So let's see here. Where would I shade? Would I shade above or below? Yeah, you'd shade above. I mean, you remember your teachers telling you about a test point? How you'd plug a point in and see if it gave you a true or false statement. If it was true, you would shade that side. If not, you would shade the opposite side. Okay. All right. What I like to do is just go ahead and compare the y to the intercept here, the y-intercept. So it says y is greater than 2. So where is y greater than 2? Well, it's only greater than above. Okay. There's all different kinds of ways your teachers probably showed you how to do that. Okay. All right. So what would you say the domain of this is? Okay. So the domain's what? Would you guys agree? I would, because every x, see, even if you're going to go like over here, you know, whatever value of x that is, there would still be points concerned with that, right? Okay. Could the same thing be said for the range? Yeah. Okay. So I would go ahead and say, and I'll go ahead and write this two different ways. So the domain is all reals. Okay. Or I could write it in interval notation with just negative to positive infinity. Okay. And it really depends on your preference how you want to write those. Okay. Does that make sense? Okay. In fact, I'm getting a little off, and I probably should wait until I do linear functions, but I'll go ahead and talk about it anyway since we brought up slope. One thing I've seen over the past couple of years, and it's just a strategy I've heard. I did not come up with it. I could see how some people might think it's offensive. I am not trying to offend anybody, but has anybody ever heard of El Slopo? Okay, so here is El Slopo. It's a face that tells you the 4 types of slope you could have. Well, what are the 4 types of slope? Slope could be positive, negative. Okay. Well, I mean, if it's positive or negative, it could be considered exponential. It's just increasing at a constant rate. If it's vertical, it's starts with a U. Undefined. And if it's horizontal? 0. Okay, so what you do is you have a negative, you have a plus, and those are his eyes. So these are his eyebrows, negative and positive. And then his nose is undefined, but a horizontal is 0. I've actually seen that in the past couple of years. I was not taught that in school, but I've actually seen a lot of students who are aware of El. Was anybody ever shown El Slopo? Or maybe it was a different name? Oh, it was a different name? What'd you call it? Slope Man? There you go. Hey, I did not name it. I think from now on I'll probably go ahead and call him Slope Man. Okay. But I'm not the one who named him. I didn't come up with it. Okay. Did anybody else besides Sierra see that? It looks like a what? Oh, no, I want to hear what.
No, I don't know what that line was.
What line? This right here?
Yeah.
Oh, that's his mouth.
I thought the line, the curve was.
Oh, no, this right here, this represents the U, but that's like his nose.
Oh.
But it also
And then you got the bridge of the nose.
with like smugness, or he's also really angry. You can't really tell.
Maybe he's mad because his nose is messed up.
And why is his nose
There you
messed
go.
up, man? Everything-
I don't. Why is his nose messed up?
Yeah.
Looks like a good nose. It's not like there's anything hanging out of it. I mean. Anyways, okay, we're getting off topic. Okay. And then this one right here. Okay. So the last one, we actually already went and talked in detail about how this is a circle. Can anybody tell me the domain and range of it? In fact, both the domain and range are the same for this one as well. Okay, Eli.
Is it negative 2?
Included or not included? Yes. Okay. So the domain and the range is negative 2 to 2. Yes. Okay. Does anybody want me to sketch it? Okay. So you got yourself a grid here. Now, this is the same as saying, you know, parentheses x minus 0 squared or x plus 0 squared. Again, it's really your preference. But the center is going to be at 0, 0, and the square root of the constant is your radius. So from here, I'd want to go out 2 units in every direction. Wow, that's actually a really good circle for freehanding. Give myself a pat on the back. So see, yeah, we're 4 units wide, 4 units tall. There we go. And then, of course, you could translate that anywhere in the grid that you wanted. Okay, good, good, good. How much is this starting to come back to you? All of it? Good. So everybody's getting the point? I got a lot more jokes for these. I taught it more years. I actually heard a really good joke the other day. Would you like to hear it? Okay. It's a chemistry joke for those of you who are kind of chemistry buffs. So Silver walks into a bar and sees Gold sitting in a corner. Says, "Hey, you, get out." Hey, you. That's a pretty good. That's a good one, huh, Sydney? There you go. There you go. Okay. Well, if you like that one, you'll love this one. What do you do when a chemist dies? Bury him. The element barium. Barium. Oh, yeah. Okay, moving on. Function. A relation in which each element of the domain is paired with only one element of the range. All functions are relations, but not all relations are functions. So basically, this is another way of saying no value of x may repeat. If any value of x repeats, it is not a function. Now, here's what can throw some people off. Is it okay if y repeats? Yes, y can repeat indefinitely. Now, that is a different topic. We have the vertical line test, but we also have a horizontal line test to determine if any value of y repeats. In fact, does anybody remember what we call that? The horizontal line test is used to tell me if a function is blank to blank. This deals with inverses. Okay. Does 1 to 1 sound familiar? That does not? Okay. Well, maybe I'll bring it up when we're done talking. Okay. Because everything's, my jokes are going over so well today. Okay. So let's see here. We'll test for functions. Check the ordered pairs to make sure that each input, the x value, gives only one output, the y value. Check to see if the graph passes the vertical line test. And, maybe your old teachers called it your pencil test or your finger test, but you go ahead and move either across the graph. And you'll notice this one's a yes, this one's a no, because if I take this line and I sweep it back and forth, what is not happening? There you go. There is never any location where the vertical line is hitting the graph at 2 or more locations at once. So that means no values of x repeat. Okay, therefore it's a function. Now some of these, the curve is almost very nearly vertical, and it does become questionable. So even on this one, if the graph were to continue, he would go down but slowly continue to the left. Okay, so no value of x does repeat. But if I did go ahead and do the same thing for the other one, okay, you can tell, well, there's pretty much for the entirety of the graph, there's always going to be values of x that repeat. Okay, so that one is no, not a function. All right. Does anybody want me to kind of talk about one-to-one or move on? Sydney, what do you think? Move on? You got it. Okay. So 3, put numbers in for x and check one input equals one output, 1x for 1y. So let's take a look at these. Number 3, function or not a function? So let's just say yes or no. 3x squared plus 2y equals 5. 3x squared plus 2y squared equals 5. What do we think? On the first one, is it a yes or no? Yes, that is a function. Okay. Would anybody like me to elaborate, sketch it, anything? Okay, so let's say we were to go ahead and solve this for y, because typically you're always going to have, y in terms of x, and you might see that written occasionally. It'll say y as a function of x. That means y is written in terms of x, so y depends on the value of x that you plug in. So 2y would equal negative 3x squared plus 5, and then y would equal what? negative 3/2 x squared plus 5/2. Okay. So think back to Algebra 2 when you had your transformations. There's actually three well, yeah, I'd say there's three occurring here. One is the negative. What's he going to do? Okay, he's going to flip it downwards. What about the 3/2? What result would he have on the graph?
It's gonna make it a lot wider, right?
A lot wider. Would everybody agree? Why? It's greater than 1. There we go. 3/2 is 1.5. Okay. So that is a vertical stretch or a vertical shrink? Okay. Okay. So shrink. Okay.
Wait, no.
Now remember, that's the question. This thing is happening vertically, so
Stretch, right?
it's going to make it thinner. It's going to make it thinner. Okay. And actually, you remember, you knew it was a horizontal dilation if it would be written like maybe something like this. Negative 3/2 x squared. So see, if it affects the x before you apply the function, then that was happening horizontally. Okay, so it's going to be thinner. It's going to be opening down, and it's translated where? Oh, not to the right. Up.
Oh,
Okay. Again, if it's going to be moved left or right, it would probably be something like this, negative 3/2 x. And what would it be if I wanted to translate this 5/2 to the right? Minus. Why minus? I wanted to go right. What kind of inverse? Opposite. There we go. All right. So when you're adding or subtracting to x, the opposite actually moves it the direction we want. If I were to multiply by x, we take the, starts with the r, reciprocal. Do you guys remember that? Okay. All right. So I'm not going to worry about really sketching it. And the point is, we're going to have a parabola that opens down. So absolutely, this guy's going to be a function. Did someone know?
Yeah.
Okay. Hello. Because no matter what direction a parabola opens, it always wants to widen as it does so. Oh, we can just put it in the tray, please. Okay. And let's see, who haven't I talked to today? Emily, help me out. 3x squared plus 2y squared equals 5. She says no. Okay. In fact, can anybody tell me what that's the graph of? It is not a circle. It looks like a circle, but why is it not? It is going to be an ellipse. Now you remember, I can write a circle to look like an ellipse in the form. I can set it equal to 1, but the two denominators, I know it's a circle, they would be the same. The fact I know this is an ellipse, if I were to divide through by the 5, this gives me 3x squared over 5 plus 2y squared over 5 is equal to 1. I just divided through by 5. But see, we don't want any coefficients in front of the variables either, so multiplying by 3/5 is actually the same as dividing by what? 5/3. So that would be plus, and then we can do the same thing with the 2/5. So that would be 5/2. And because those denominators are not the same, I know this is an ellipse. Okay. And which one's bigger, 5/3 or 5/2? 5/2 is larger, right? Okay. So because the larger value is below y, this guy, the major axis, would be vertical. But still, you can see he is not going to pass the vertical line test. In fact, on your test tomorrow, I said I was going to give you some of those. In fact, all I did was just give you a few graphs, and you're going to tell me yes or no, function or not. Okay. So that's the only aspect from this that's going to be on the exam. Yes, ma'am.
Wait, why would it pass the vertical?
Well, because we've got an enclosed figure here. So if I were to go ahead and put a vertical line through, see, there's going to be a lot of places where I have repeating x's.
So the x's can't.
The x's cannot repeat. That's our one rule. If they repeat, it is not a function. And in fact, now with these new calculators, the Inspires, they do have the form you can use for conics. You can actually just go ahead and plug them in the calculator now. Back in the old days, like in my day, if we wanted to go ahead and see like a circle or an ellipse in the calculator, we'd actually have to solve for y. And again, would you like me to show you that, or No. Nobody wants to see it? But the point is, how would I get a y from y squared? So you'd have to take a square root. So when you take the square root, you'd have a positive or a negative one. So the positive would be the top portion of it, while the negative would be the reflection. And that's how you'd be able to get the entire thing. Okay. I'm old. Okay. All right. So let's go ahead and take a look at some other relations. Okay. Sorry. That's actually the school calling, too. That's weird. Okay. All right. Which of the following defines a function? Okay. So basically, again, just yes or no. What do we think? 0, 2, 1, 2, 2, 1. Yes. But wait. Y's repeat. It's the x's we want to look at. Okay. No value of x is the same. So yes, this is a function. Okay. Now remember, this is what we call a solution set. So it's all ordered pairs x, y. What's the colon mean? It's been a while since we talked about that. 2 words. Such that. Okay. So all ordered pairs such that, and then here's the restriction. Your function is y equals x cubed plus 1, and then x belongs to the reals. So x is any real number you can think of.
Yeah.
Does anybody remember what x cubed looks like? Kind of. The cube is x cubed is going to look like that. Okay, that's x cubed. So the inverse looks like that elongated s. But this one, I would then shift it up 1. So this one is definitely a function, yes. He would pass the vertical line test. Okay, no value of x would repeat. What about this one right here? Y squared is equal to x.
Yes.
Now, let's make sure to go ahead and solve it for y, because y is the independent. So what would I do to both sides? Square root. So I would have y is equal to square root of x, but plus or minus. And remember what I was talking about a second ago, how I used to have to graph these on like the 84s? Okay, 1 positive root, 1 negative root to get the whole thing. Okay. So think about what's the square root of x look like? Yeah, it's just half a parabola, right? So it starts at the origin and it curves over like this. So that's the square root of x. So the negative would give you the reflection. Okay, so that would not be a function. Okay. In fact, if you remember in Algebra 2, when you were talking about inverses, if your inverse was not going to be a function, you had to restrict the domain of the original in some way, because we always love our inverses to be functions. Okay, so this one we got to say no. And you'll notice it is greater than or equal to 0 for the x's. Okay. All right. And what about this last one, D? All ordered pairs, x, y, such that x squared plus y squared equals 16. Well, what would that be? Is that a circle or is that an ellipse? That is a circle. Because if I divided through, would both denominators stay the same? Yes. Okay. So regardless if it's an ellipse or a circle, is it a function? No, it is not. It is not a function. Okay, questions. Anybody having a hard time? Easy? Okay. Nice. So we're putting the fun back in function. Oh, hey.
Can you go back to that other one?
Well, which one, man?
What was that other graph called? Okay, see the x cubed graph?
Oh, yes.
What was that? Like, whenever you turn it, what's that called again?
Oh, you mean if I took the inverse?
Yeah.
You talking about this one right here?
I think it was, yeah.
Okay, well, this one is the cubic function. This one is the cubed root.
That's all.
Oh, no? Am I not understanding the question? Or?
No, I just wanted to know what it.
Oh, okay. All right. So we got to the root of that problem? I'm on fire today. Yes. Okay. Tell by your stony silence I'm correct. Okay. Function notation, which we talked about earlier. The set X is called the domain of F, and Y is called the range or codomain. And this is, what's I've seen confuse a lot of students over the years. So there's a lot of different names for it, but whatever's put inside, this is your input. That's the X value. Okay, that represents the domain. Okay, or at least an element of the domain. But at large, F of X, that is your output. That's the Y value. Okay. All right, so there is a difference between the two. In parentheses, that's the domain, but F of X is the range. And we read it, F of X. Okay, so example 5. Determine the range of the function y equals x plus 1. Well, what kind of function is that? What would it look like if I graphed it? It's linear. Okay, he's not in line. Yes, see how he went straight ahead. Yes, it is 1. Wow, man. I don't know whether to try and keep going or just kind of just let it go. I think I'll keep telling more jokes. Okay. So it's crossing at 1. It's got a positive slope. So what's that mean? It's going to be rising or falling to the right? Rising to the right. Okay. So remember, slope man. Okay. I will no longer call him El Slopo. I did not come up with the name. Don't, go tell your parents. Listen to this video. Mr. West is not woke. Okay, so don't do that. Okay. All right. Okay, so what is the range? How high and how low does he want to go? What would the range of this guy be? Basically, how tall? All reals. Yeah, I mean, he's going to go up forever. He's going to go down forever. So any value of y will have a place on this graph. So the range, negative to positive infinity. How much time we got? It's 2:02. Okay. It's a good day. Okay, number 6. We're actually down to 2 left. I'll tell you what, there's no rush. I'm thinking we have our test tomorrow. We'll go ahead, probably answer a few questions on Friday if there are any. Why don't we go ahead and just wrap this up on Friday as well? Okay, and then that'll be a good way to end the week. Okay, good. Oh. We've only got like 7 minutes. Is it? Hold it. It's an emergency. And also, I completely forgot Peyton has me earlier as well. So,